Hi guys, in this video I'm going to go through how to track the energy changes that take place in a reaction. When bonds are broken or bonds are being made, energy is going to be released in the form of heat or taken in from the surroundings. If energy is given out, we say that that reaction is exothermic. If the heat increases, that's what we've seen, it's exothermic. If the temperature goes down, we can say that that reaction is endothermic. So what I have here is two polystyrene cups inside a glass beaker, and I have some chemicals which I'm going to react together, and we're going to see the progress of that reaction and see whether the temperature has gone up, and if it has, then we have an exothermic reaction, and if the temperature goes down, we have an endothermic reaction. The first reaction that I'm going to look at is ammonium chloride and distilled water. So I'm not actually going to measure out the distilled water, but if you were doing a controlled experiment, you would use a measuring cylinder to measure that out. And it's key to take a starting temperature. So let's pop our thermometer in and take a starting temperature. It's around room temperature at 21 degrees C. The next one, we are going to do a neutralization reaction. You might already know whether neutralization is exothermic or endothermic, but let's just see. So I'm going to put some sodium hydroxide in, and I'm going to put some hydrochloric acid in. Remember to take the starting temperature as well of that. Alright, so we've taken our starting temperatures of our two liquids that are already in there. So on the right here I have some distilled water, and on the left I've so far added some sodium hydroxide. So now it's time for us to add the other reagent and measure to see how much the temperature goes up or down. You'll notice also the thermometer has a lid on top of it as well, and there's a reason for it. The lid is to make sure no heat escapes to the surroundings, and also you can see that the polystyrene cup is inside a beaker as well. I'll just turn the thermometer so you can see it. Don't worry if you can't see it just yet, I will do a zoom in of that. But I'm adding the hydrochloric acid to this one now, to the sodium hydroxide, and we'll leave it a couple of minutes and see whether the temperature has gone up or down. So what we observed is over here with the hydrochloric acid and the sodium hydroxide, that reaction was exothermic. The heat increased. In fact, if I take my hand and put it onto the polystyrene cup, I can actually feel some of the heat that is coming out of that. And if I read off the thermometer, the starting temperature was around 20 degrees. My classroom is a bit cold. It's now at 25 degrees C. And here, the ammonium chloride with water, that is reading now 15 degrees C. Oh, very chilly. If I give it a stir, I reckon I can get it even colder. Oh, it is going down a little bit more. And you can actually feel on the polystyrene cup that it is very cold. Now, the key to doing a reaction like this is avoiding heat loss. And the way I've done that is by putting the lid on top of my beaker and putting my polystyrene cup in the beaker as well. Now, the results I've taken haven't been that accurate. Thermometers are good up until a certain point. To get more accurate results, what you would use is a data logger like this. This is called a temperature probe, and attach it to a data logger, and that can monitor temperature a lot more accurately. Thank you for watching, guys.